Hello everyone. So now currently you guys are looking at my MATLAB screen, and we are trying to do this first program of your basic signal processing lab. So what are we trying to do here? Uh, so we are trying to do two things: program to create and modify vector, and create and modify a matrix. So what is a so the experiment says, some experiments are quote arrays and some of them quote matrices. So usually matrix is a special case of array which is usually two-dimensional in nature. An array can be one-dimensional, it can be two-dimensional, it can be three-dimensional, it can be four-dimensional, whereas matrices, okay, a matrix is usually two-dimensional in nature. Okay, so what we will now do is we will try to learn some of the simple commands which will help us create or modify arrays. Okay, so the commands which I want you guys to go through are, so you can see here what I have done is you can see this yellow thing here in MATLAB. It is showing an error. What does it say? Terminate statement with semicolon to suppress the output within a script. Okay. Now I have not put the semicolon. You can see me putting a semicolon is going to remove this particular warning. Just I am not going to do it because I want to observe the output here in the command window. Now let me simply clear the command window, and let me just clear the workspace also. Here you can see on the extreme left bottom there is workspace. I had executed some earlier programs. So let me just clear all those variables. I think see now my workplace is clean. My command window is also clean. And I am currently pointing to the, wait a second, let me point to the folder which, which is my default folder, which is my documents and the MATLAB folder. Okay, so this is the folder that I'm going to select. Okay, you can see this is my current folder. This is my workspace. Here I get all the outputs, and this is my command window. Every line written in command window simply gets executed. Whereas this is an editor, which lets me write all the commands at a time, then execute them at a time. Okay. So the first thing which I want you guys to know is, creating an array in MATLAB. How do you do it? You can see here. Now this is my command. Let me just select it and evaluate selection individually. You can see here, what did I do? I used a square bracket. Then I used a space. You can see here, it is showing me in the workspace an array of size 1 cross 5. Okay, if at all I want an array of size 5 cross 1, what I need to do is I need to have between the elements, I need to have semicolons. Now see here, if at all I put a semicolon here, if I put a semicolon here, then what's going to happen? Suddenly, it's going to be a 5 cross 1 array. Shall we check? Earlier, I did not put the semicolon. You can see here the previous command. Now I put a semicolon here. Now let me run it once again. See, I have put a semicolon here. So the command only shows. Let me type an A here, the variable, and you can see. Now it is a, you can see even in the workspace, it's not a 1 cross 5, but it's a 5 cross 1. Okay. That's that. Now let me revert back to the previous one. Okay. Like that. Okay. Now, what is the other thing what we want to do? So the task of this particular experiment is to create and modify an array, accessing array. What if I want to have particular elements? So you can see this is the first element, this is the second element, this is a third element, this is fourth, and so on. In MATLAB, remember, there is no zeroth element. Usually in logic design or in microprocessors, everywhere, okay, even for normal signal processing in the time domain, we usually have this habit of starting from 0, whereas in MATLAB it always starts from 1. Okay, so you can see me writing an A of 3, A in the normal brackets. If it all write 3, this is pointing me to the third element, which is 11. Okay, which is 11. So this is how I can access a particular element maybe. Okay. Now, if at all I want to change it, you can see what I have done is I have taken some number 45 and I'm assigning to a of the third element. By doing so, okay, you can see here in my workspace. Now I have executed this third line here, the 11th one here. You can see the third value in my array A has been changed to 45. Now you can see one more thing. My array, even though it is a 5 cross 1 or 1 cross 5, since it is one dimensional nature, A of 3 will be moving in the largest dimension only. Okay. Now what else can you do? What if you want to create a one? Now this is the case of a 1 cross 5 array. Now here you can see what if you want to create a two-dimensional array. How do I create a two-dimensional array? Let me have an array v equal to. Now what do? Let me have the first row, 1 space 2 space 1. Then let me have a 2 space 1 place 2. Okay. Now you can see I used a semicolon which will take me to the next row. Now this here is an array. Let me just execute it. This is an array which is 2 cross 3, 2 rows and 3 columns. You can see 1 2 1 2 1 2. Okay. If at all you want to create a three-dimensional array, what you can do is see, you can see this one here. Okay, 1 2 3 followed by a semicolon, 4 5 6 followed by a semicolon, 7 8 9. That's a 3 cross 3 array. Okay, you can see that's a 3 cross 3 array. And what can you do by the with element? You can easily access any of those. You can change any values. You can see the second row and third column. I'm changing it simply as 3 multiplied by the second row, third column, and simply first row. Okay, you can do any kind of things. Okay, you can access individual elements. Okay, if at all you want to have all the elements in first row, you can see here 1 comma colon. Now, if at all I put a 1 colon, comma colon, what it means, it pick all the elements in the first row. Okay, pick all the elements in the first row. That means if I execute this, I should get a 1, 2, and a 3. Should get a 1, 2, and 3. If at all, instead, if at all I do a colon, comma 1, say if at all I do, say a colon, comma 2, for example. Okay, say let me do a colon, comma 2. Now, can you guess what's going to be the output? You can see this is the matrix what we are talking about, colon, comma 2. So in the second column, pick all the values in the second column. So I am expecting an answer, something like a 2, 5, and an 8. Okay. That's how you can access an individual row, an individual column, or any individual element. Now, not like C. Now, this MATLAB is very platform. You can see here I have created an array which contains a real number, which contains a integer, it contains a floating point, it contains a real number, it contains a complex values also. Okay, it's all fine. They are not memory efficient, agreed. But then in programming, you can concentrate on the the theoretical aspect rather than the technical aspects. Okay, you can see here easily array has been created. Okay, of mixed data types. It's neither an integer nor a floating point, nor it's a real data. It's a complex data. Okay, that's possible. Can you create a three-dimensional arrays? Yes, we can. Okay. Now you can see this here. I have written a randi. Randi is a command to create any random elements. Okay. Now let me try this randi here. Let me do equal to, wait a second. Randi stands for random integer. Okay, it's a random integer. So if at all I give a number here, 4 comma 1 comma 4. Okay, now let us see what has happened. So the meaning of this, okay, so whenever we are coming across these kind of new what do you say, new variable. Okay, if it are a new command, sorry, if it only come across these kind of new commands, then what you can do is, I don't know much about the randi. What does it do? So what I will do is I'll go to here command window, help space randi. Okay, so if at all I do this and I press enter, now you can see a decent help pops up here. You can see a help has popped up and it has several examples. Okay, you can see here it gives a nice examples and it shows exactly what does the function do. Okay, random, pseudo random integers from a uniform discrete distribution. Okay, are resulted. Okay, you can have this chunk of codes. Maybe you can select it and right click and you can evaluate. Okay, that's how it, and all the related ones you can see along with this randi. There is rand, there is random. Okay, all other things also. Okay, so let me come back now to the function randi. Now, what is the meaning of this statement here? Now, this is going to generate random integers of size 1 comma 4. Okay, of size 1 comma 4. All the numbers are going to stay within or equal to 4. Okay, now let me just run this particular thing. You can see now 3 3 4 3 1 cross 4 array was created. Okay, 1 cross 4 array was created. Okay, now can we do, go to higher objects? You can see here for this particular command. So what does this instruction do? When I did a 1 comma 4, it was a 1 row and 4 column. Now here what I've done is I have used a square bracket and I've written 3 space 3 space 4. So this is going to create an array which is three dimensional in nature. Okay, now let me just evaluate this. You can see this is going to create an array which is three dimensional in nature. Okay, so are you getting this? You can see here. Wait. Okay, okay. Up arrow. Yeah, now you can see. So you can see here. This is the third dimension. Okay, this is the third dimension. There are four such. Okay, see this one. This is two dimensional. A 3 cross 3 two dimensional, 3 cross 3 array. These are two dimension. Then see, you can see there is the third dimension which is having four elements. So this is the first 3 cross 3 matrix. This is the second 3 cross 3 matrix. Then a third 3 cross 3 matrix and a fourth 3 cross 3 matrix. Okay, so that's rare. So where do we encounter these kind of three-dimensional things, by the way? Maybe you might have come across. Usually happens in your field theory. Okay, in mathematics also maybe. Now the nearest thing which we can relate usually. Okay, is usually images. Okay, so what I am going to do is for our convenience, I have pasted this particular image here, that of a mandrill, the baboon. Okay, so let me just open it here. So I will open it outside MATLAB. Okay, I don't know whether you can see it or not. Wait a second. Uh, New share. Okay, now, okay, this is the image that we are talking about. Okay, so I have pasted this particular image in the MATLAB. I have pasted this particular image. Now let me go back. Now let me go back, and what I will do is, you can see in the current folder, it is, I have pasted that particular thing. So now I will read this particular data. Okay, using the command im read. Okay, so what am I trying to do here? I am just trying to show you how a typical three-dimensional data is going to be. And also I want you guys to stress on the data types also. Okay, so this is part of the activity which I asked you guys. Okay, so what is it, by the way? So whenever a color image is formed, it is supposed to contain three dimensions: one for red component, then there is green component, then there is blue component. An image on its own. Okay, let us see anyway. Okay, let me just execute this. What is the command? By it's a TIF image, by the way. So the command is im read. I am reading all the image parameters into the variable im. Okay, so here it is. Now can you see? It's 512 cross 512 cross 3. Okay, so 512 cross 512 are the rows and the column pixels. Understood? Understood? Okay, and 3 here, what does it indicate? So 3 here indicates the red, green, and blue planes. Okay, now what I will do, I will just open this thing in MATLAB by using the command im show. Before that, let me just type in im here in the command window just to show you how do these numbers look like. I'm just simply type in this command here. You can see. Now, can you see what are these numbers here that have popped up just now? So you can see all these numbers. These are 512 cross 512 cross 3. Okay, you can see there are a lot of numbers. Okay, and what is the data type here? the data type here, you can see previously, remember we typed in a random data 3 cross 3 cross 4, but the type was double. Okay, you might be knowing, right, what are these data types. There is integer, there is floating point, there is complex, there is double, there is boolean, and then there is unsigned integer. Usually image data, you can see so many numbers here, right? So the minimum number that you are going to come across here for images is going to be 0, and the maximum intensity that you are going to come across for an image is a 255. So that's an unsigned integer represented using only 8 bits. With 8 bits, you can represent how many numbers? Starting from 0 to 255, totally 256 numbers. That's what an unsigned integer means. It is always positive. Okay, such integers are always positive. That's why the name unsigned integer. They cannot be fractions. Okay, that's how an image is usually made up of. So the idea is image is usually while being captured, it has a separate red, green, and blue components. So let us now see the entire image. So what I will do is I will do this particular IM show IM. So the same image now is going to pop up in MATLAB, by the way. Wait a second. We are waiting. Let us see what's just happened. Where's the image? Okay, 1 second. Okay, so now let me new share here. Now I hope you can see it now. See, I hope you can see this is the image now I have opened in MATLAB by using the command im show im the variable. I did not give the file name, but I only give the variable. Now this is our my three-dimensional data of unsigned integers, which is being interpreted as an image. Okay, it's a three-dimensional data which has been interpreted as a image. Okay, now let me go back and now let me make slight change here. Now let me make a slight change. Okay, so now what I will do is, so as I told you, there are going to be three dimensions. The third dimension, by the way, is three. It indicates the first one indicates the red plane. The second one indicates the green plane. Third indicates the blue plane, which is the contribution of red, green, and blue. Did you see the image of this particular mandrel, by the way? Okay. So let me again take you back. Just observe it very carefully. Mandel. Okay, you can see the nose of this particular mandel is red in color. So a red in color with some shades of a blue. So the green and blue are definitely missing. And here you can see on the sides there is a blue cheeks of it. And then there are those fur sort of thing. They are a component that seems to contain greens and blues. Okay, now for in this particular nose area, there is a large contribution of red, but in this area, there is not much of contribution from green and blue. Whenever the contribution is more, we are expecting lighter shades, and whenever the contribution is less, we are expecting darker shades going towards zero. Okay. So now let me go back and let me just show it to you. Okay, you can see now I am going to show you only the red component here. Evaluate selection. Now is the red component. So just now I had told you what's going to happen. So now here you can see. Okay, now can you see here? What did I tell you? The nose of the particular mandrel, it was red in color. So whenever there is a contribution of a particular color, the absence is indicated by a black, maximum contribution is indicated by a white, and if there is 80, it's a medium. So it's on the scale from 0 to 255. 0 indicates no contribution of a color. 255 indicates maximum intensity of a particular color. Then there can be an 80, there can be a 120, there can be a 160, there can be a 210, there can be a 240, going from the darkest grays to the whitest white. Okay, so this is the contribution of the red one. So wherever there is whiter colors, it shows the presence of red. Wherever there is black, okay, or the dark grays, it shows the absence. Now let me show you the same thing with the greens and the blues. Okay. Now let me execute the second line here. Now let me execute the second line here. So this second line here is usually the green color. Okay, the contribution of green, sorry, it's the contribution of green. And third one is the contribution of the blue. This is interesting. You remember the cheeks or the chin, cheeks were blue in color, remember? Now I executed this. Now let me take you to this particular image. Okay. Which is the contribution of blue for a change. Okay, okay, now you can see, you had seen this particular mandrel, right? The nose of the mandrel was red in color. So it has zero contribution from the blue, except for the mid where there are some shades of blue. That is why wherever there is red, there is absence of blue indicated by black. And you can see the cheeks where, is it the cheek performantal? Okay, whatever. Okay. The cheeks were blue in color, indicating the maximum contribution of the blue. And then here on the other sides, there were, contribution of all such colors. So it's an interesting study image, by the way. It's one of the standard test image. Okay, the mandrel one. Okay, so that's how you can see. So what was the whole intention of this exercise? So we wanted to show you that data can be three-dimensional array also. This was a three-dimensional array. The second thing which was interesting for us was the data type here was something new to us. It was an unsigned integer. More about this you will come across whenever you're trying to manipulate some data, I guess. Now let us see an audio also. What's the deal with an audio? Now I have placed one audio file here, time.wave. Is it there, the file? Okay, sorry, the file is missing. Okay, wait a second, let me try to have the file. Okay, so now I have brought in this particular file, time.wave. It's a normal audio file where some lady is telling the current time. Okay, telling some time. Okay, I doubt if at all I play this thing here, you can hear it on your screen. Okay. I don't know how it was, but let me read this file as, let me treat this audio as a data, just to show you what's going to be the nature of this particular data. So I use the command audio read, and it has been assigned to variable. You can see audio, for example, the image whichever I read, it was three-dimensional. The red plane was two-dimensional. Audio file, you can see, is a one-dimensional file. You can see some numbers cross one. It's a one-dimensional thing. The data type is double. Okay, the data type is double. Okay. That's it for this particular video. So we made a little effort to create a matrix, an array specifically. We kept it simple, usually 1 cross n or an n cross 1, but array can be of any size. We have seen it, but we have not yet encountered any situation where we might want to manipulate higher order array sizes. That's why we kept it limited. But I hope the direction in which we are supposed to proceed. Okay. So that's it. If at all you have any doubts, ping me.